works, it works. It doesn't work, you get no points. Simple as that. For me to actually examine your code, try to figure out why it doesn't work, there's no way, right? That's not feasible. Nobody in their right mind does that. Other universities, when they have like 200, 300 students per class, nobody does that, all right? It's just they send it through um, a program that determines whether or not it produces the right output given certain inputs. That's it, and that's what I'm doing here, all right? So it's more pressure on you, but hey, this is how it is, all right? Um, you guys have any questions or? Oh, one more thing, right? For that driver program for the quiz, some people gave me like names that did not match up. For example, some people did not give me their list node class. Instead of naming the pointer next PTR, they named it next. Instead of spelling the list class with capital L, I don't mean the file. I don't mean the file. I mean the class itself, capital L for list. They named it lowercase l. And those are additional things that I subtracted points for. Every time I plug this thing in and you make me have to fix your code for it to run base, just compile, woo, you lose lots of points. All right, because at this point, you should be giving me at least something I compiled and run. Now, I'm sure not every function might work, but at least this thing better compile and run. That's why naming is very, very important. All right. Like I said, having to tweak your code so it works with my driver, that's a big no-no. All right. So ensure that your classes, data members, everything are named properly, that you can call the functions. At a minimum, make sure that you can call the functions. Even if the function does not produce the right result, make sure that the function can be called. In fact, I would say if your function does not work 100% and you like, the hell with this function, do not leave it out. Put the function body and comment out the code inside so that it just runs, produces no result. You understand? Or it returns a default value, but doesn't actually uh, crash or anything. Because I need those functions to be available in your code. When I say available, I mean even if the body does not exist, you have to put the opening curly brace, closing curly brace. The contents of the body might be empty. You comment it out if it's completely flawed and you can't fix it. But I just need for the function to run when I call it, even if it does not produce the right result. Is that clear? Because that's going to affect my driver. And every time I have to fix your code for that, that's more points that I take off. All right. So any other questions that you want me to answer before we get into operator overloading? Because this is a little bit of a tricky topic. It's not tricky. It's not tricky, but it's different. So I want to answer your questions before I start that. Any questions? No questions. We're good.
Yes, sir.
All right. Let me just check the chat to see. Sir, would you want us to type out the code in? Yes, I want you to type out the code. Yeah, code is typed out. I mean, the thing is, I want you to type out the code because I want you to test it before you send it to me, so that you already know what disappointment you're going to be to me. All right. So I want you to feel a disappointment before, and there will be no surprises. Because sometimes when people write down code on paper, right, like in a test, they honestly think that their code is like really good, and then when I go through it, uh, and I find out all these flaws, and like what? So it's good. Type it up, run it, so you can already be disappointed before you send it. All right. So at least you're not going to be surprised when you get a low grade. If you get a high grade, then you might be equally surprised. I don't know. So yes, you can type it up. Right. You have access to everything. Right. We're not gonna pretend. Let's not pretend. Let's none of us pretend that you guys don't have access to all sorts of resources. All right. So for me to ask you to write it proves nothing to me, right? It just proves that you typed it up and then you wrote it after the fact, right? So let's not even waste time with that. In a test, in a real paper test, of course, you're going to have to write it. You will not have access to these things, but the environment that we're in, we're going to work with that. I'm not stupid. So you're going to type it up. You're going to test it to see if it works. If it doesn't work, well, at least don't be surprised by our grades. We're good? Bueno.
Bueno.
Okay. So how much program sets will we get? Um, you get one for linked lists, one for stacks, one for queues, and then the trees will be your basically your exam. Like it's a mixture. The trees program would be considered, a portion of it would be considered as your fourth program set, and it's also going to be considered as your exam. We get to see our test to see what we did wrong. I can do that, but I need to cover this material first, because I know once I go through a test, people are like, but how about this and that, and that's going to take up time. So right now I'm just trying to answer like questions that will, but immediate like things that you need to know right now for like next week or stuff like that. I'm trying to answer those, but we can always revisit the test number 1 to see what you did. It just might not happen today. That's all. But yes, for sure, I have no problem doing that. I have no problem. Any other questions? No. All right. So what I'm going to do is I'm going to share my screen so you can see Qt, and I'm going to write some code and I'm going to explain it. As I go through this, please stop me if you get confused. I don't know if the book actually covers this topic, so I'm going to try my best to do it for you, right? Review the test 2 answer. I can't review test 2 unless we do test 2 first. Once you do test 2, I'll review it. Okay, so now with answers, I'm going to give you a general idea of how to solve it. Here we go. So, oh, forgetting to share my screen. Share it. Right now is operator overloading, because you need to do that for your program set. Can you see my screen? You should be able to, right?
Yes,
Okay.
sir.
Yes, sir.
Let's begin. Let's make this really simple, right? So if I have this, I have int x, y. I say x less than 9, and then y less than 7. I can do cout x, y. I could do if x is less than y, cout x less than y. Okay. I can say if x is not equal to y, right? So don't worry, this I'm going to explain what the heck I'm doing. All right, so having said that, if you look at this code, you will notice that I am doing very basic operations, right? So x and y are of type int. And when I do this, what do you expect to see on the screen if I run this program? What do you expect to see?
Only 9 is not equal to 7. The second execution.
What about this line, line 12?
Oh, yeah, I'm gonna print that too.
Right? No,
Yep.
you're probably thinking, okay, yeah, I know that. That's going to work. But the question is, right? How does he know what to do here? How does the compiler understand what he's supposed to do here? Because what you're doing here is you're saying compare an int with another int. And if the first int is less than the second int, I want you to do something, right? That's what you're doing. How does the compiler know how to do that? Well, if you recall, I told you that int, float, double, char, not string, long int, long, double, byte, short, bool, these are all primitive types. They form the, I guess you could say, the fundamental types in the language. With these types, you can create more complex types like objects, right? Now, because these come with the language, right? These are core to the language. These things already have been designed. Let's backtrack a little bit. What's the official term for this guy? Don't tell me what the name is, but what is this guy? What's the official term for this? Is a what? An
Less than.
yes, but what's the generic term for this dude right there?
Oh, given already.
operator.
Operator. It's an operator. Is this an operator? Line 15, is that an operator?
Yes.
How about this? How about this? How about oops, that? How about that? All right. Are these operators? They're all operators. Operator. Operator. These are all operators. Okay? Operators. Operators. All right? These are all operators. Okay? These are all operators. Now, what makes these things special is the fact that they already have, what can I say? They already know how to behave in certain circumstances, right? For example, this plus operator knows that the operand to the left should be added to the operand to the right. So he's expecting two operands, right? This is an operator who's expecting two operands, a guy here and a guy there. And what he's going to do is he's going to find the sum. The subtraction is the same thing, all right? This one is different. This is the unary plus. So that's going to expect one operand, and he's going to increase it by one. And similarly with these things, okay? So these things have already been given a definition. The language has already defined it. Said, hey, when you see something here and something here, if it's an int, this is what you do. If it's a float, this is what you do. If it's a double, this is what you do. You understand? It's part of the language. So you didn't have to like explain this to the compiler. Compiler says, wait a minute, this guy, yeah, let me check what the language says. Oh, if there's an int on the left and an int on the right, I know what to do. All right? If there's a float on the left and a float on the right, I know what to do. These things have already been designed as part of the language. Does that make sense? So you and I don't have to worry about it. We just use it. We don't even think about it. We just use it. Now, operator overloading is doing exactly what the name suggests. You're overloading the operator. In other words, think of it like this. Think of it like you're a rich bastard, right? And you have a chauffeur. And your chauffeur drives you around. And then you decide you're going to overload this chauffeur, right? And think of the chauffeur as the operator. You say, look, James, and I don't mean James Faber, right? This is another James. So you say, James, you've got to do my laundry, James, right? So I'm overloading poor little James. James was first he was being my chauffeur, driving me from point A to point B, but now I'm overloading James to now do my laundry. All right, and another day I can say, James, you've got to cut my nails, my toenails especially, James, right? So I'm overloading James's responsibilities. Does that make sense? That's what operator overloading is.
Makes a lot of sense.
Huh?
It makes a lot of sense.
Makes a lot of sense, right? Especially once we use James as an example. That's makes things even
poor James, man.
Makes
Poor
the
James.
concept definitely sink in. So what's happening here is that what you're doing is you're telling the compiler, listen, compiler, I know that this guy behaves a certain way, but I would like to add to his functionality. I would like to overload him. In other words, I would like to give him more responsibility. That if you see this guy being used in a different situation, I want you to do this. So remember, all of these things have already been defined. They've already been given a certain responsibility. They know that if I see a into the left and into the right, I do this, or whatever it is, they know. Operator overloading is saying, I want you to add more functionality to an operator. You pick the operator and you can add more functionality. For example, if I'm not mistaken, these two cannot be overloaded. There's some operators that the language just explicitly prohibits it because it can create lots of problems, okay? But like these guys, these can all be overloaded. Even this dude here, this guy can be overloaded, right? So my point is this. When you're talking about operator overloading, all you're saying is, you're telling the compiler, you're saying, hey, Mr. Compiler, yeah, you pick your operator, you get to pick which one. You say, I would like to overload this operator. In other words, I would like to give him new functionality besides what he has. It doesn't mean that when you add the things he could do before all of a sudden disappear. It just means in addition to what you do, like James, the chauffeur, you now have to do my laundry and cut my nails, right? So I'm telling these operators, in addition to finding the sum of blah, 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 you're now going to do something else. Does that make sense? I first need for you to understand the concept. Does the concept of operator overloading make sense? It's just basically adding functionality to operators. Does it make sense?
Yeah.
Good. Now, let's see where this becomes really important, right? So I'm going to create a new class I'm going to call this class rectangle, right? Rectangle. Finish. And come on, buddy. You're so slow, my friend. Okay, all right. So now it's a rectangle, and I'm just gonna add some data. Let's add two data members. So a rectangle has length. Let's say float, length, float. Okay, that's those, and then let's create another constructor that says float length and float width, and then what else? Okay, and print. Void print. Okay, let's do that. So I'm going to implement these. Okay. Target. I'm just trying to. Okay. I'm going to add this factor, add definition to that. Okay. Okay, that's it. So now I'm going to implement this. This one will just say length is assigned 0, width is assigned 0. This is all really stupid code so far, right? I mean, this is what you should know. This one I'll say length is assigned L, width is assigned W. Nobody cares about that. And then cout, I'll print. This is what I'm going to print. The rectangle's width is its length is okay. Let me just add up here. Don't do using namespace std. I'm just doing this because I don't have time to type up all that stuff. Okay, here we go. So now I come here and I'll comment this out. And we're going to build an object. Oops, gotta do this. Fonts and include. Right. Okay. So now I'm going to build a rectangle object. So I'm going to say rectangle R1, rectangle R2. I'm going to pass in, let's use simple numbers so that I can do this stuff in my head. Otherwise, you know, right? It's not good. All right, and let's do another rectangle R3. Let's say 2, 4. I don't remember which one is length. Which one is length? Length and width. Okay, good. Here we go. So now, if I run this, right, and I do r1.print, it's time up already. Anyway, r1.print, r2.print, and r3.print. The reason I'm not using STD is because I'm lazy to type STD and I want to quickly get to the point. But you should always use STD. All right. How many of you guys are familiar with STD? Okay, so I'm going to continue. You shouldn't use namespace STD. It's always good to explain very clearly what libraries you're bringing in. Okay, so if you look at this, it says the rectangle's width is 0, length is 0, but prints out everything for us, right? Now this is pretty straightforward. There's nothing, I didn't do anything special there, right? Now, what if I did this?
Sir, you already show Qt, so I'm gonna say where the window prints. I mean, where print per command prompt.
Oh, serious?
Yes, sir.
Oh. Okay, well, I guess I have to. Hold on 1 second. Okay, start to share. Share.
That happened when you shared like just certain windows, or you have to like share your entire screen or something like that, and then it's gonna show it.
Okay, let's do that. So now you can see, right? Let me run it one more time. That's what it does. Can you see it?
Yeah, we could see it now.
Yes,
Okay.
sir.
So now, so far this is straightforward. There's nothing special. I didn't do anything special in this code. Like this is programming 1 stuff. All right, fine. Now this is where it gets a little bit weird. If I did this, what's gonna happen? Why is he complaining about this? Why is he complaining? Come on, guys, tell me. Why is he complaining? How come this didn't complain? All right, if I uncomment these. How come this didn't complain? All right, I said print X. Why is he complaining about printing my rectangle?
R1 is an object.
And
it contains more than one variable. That's why you don't know how to print like various variables at a time.
so, and he doesn't know like what you want to print to the screen. Besides the variables, he doesn't even know what to print, how to print it, what format, how many lines do you want me to print? Do you understand? When the compiler, when you do this, the compiler goes, oh, okay, you want me to print this guy. Now, the question is this. Is class rectangle part of C++? Yes or no? Is class rectangle part of C++? Is it a prepackaged language, in other words? I mean, class. No, it's not. We made it. So from the perspective of the compiler says, okay, you want me to print this rectangle object. So what is he going to do? He's going to go on his merry little way, right? And where is he going to go? He's going to go looking somewhere. Where is he going to go looking? Where? Where is he going to go? He's going to go to your rectangle class. And what is he going to look for? What is he looking for in your rectangle class? How to print. He's looking to see if you actually overloaded this operator to tell him how to print this object. And when he comes here, surprise, surprise, he sees that you have nothing to tell him how to print a rectangle. Do you understand? So immediately he says, sorry, dude, I don't know how to print this. I don't know how to print this.
My gosh.
Does that make sense? So this is the problem. And it keeps on going. It's not just that. What if I wanted to do this? What if I wanted to say, if R1 is less than R2? All right? Cout less. Let's just say, right? Again, compiler looks at this and goes, you want to compare one rectangle object with another rectangle object. What's going to be the same issue again? What's going to happen?
Well, what the
guys, you've got to be muted, eh?
Front of me on the right. What the fuck?
Well, hey, guys, you have to mute your call.
On the left, on the left, on the left, on the left.
Golly!
Hold on.
Bali that play video games, sir.
Hold on.
Fam.
Man, they play PUBG, sir.
Guys, you have to make sure your mic is always on mute. Only when you're speaking or answering a question that has to do with this class, do you unmute yourself and then you mute yourself back, right?
If you're using a laptop, you can just press space bar for push to talk.
This is why this damn dude is Ivan the Great. Learn from this guy, damn it. You see how he keeps on giving me some helpful hints?
No, I just need to learn how to do programming.
You know how to do programming, dude. You know how to do it, so don't even pretend. All right, so, okay. Back to this. So this is gonna run out soon. So when you do this now, right? When you do this, same problem, right? The compiler looks and goes, you want me to see if a rectangle object is less than another rectangle object. Compiler is going to basically say, I don't know how the hell to tell if a rectangle is less than another rectangle. So what does he do? Like before, where does he go? He goes to the rectangle class. And what is he looking for? What is he looking for? He's looking to see if you have overloaded the less than operator. And then he can run that code. But obviously when he goes, he sees this dude did not overload it. And he complains and says, I don't know what to do. And I can keep on I can keep on going with this. I can say R1 is assigned R2 plus R3. All right. And again, he's going to go, what the hell? You want me to add two rectangle objects? I know how to do that, but let me check to see if your class tells me how to do that. And again, he checks. All right. He checks and he says, nope, you didn't tell me what to do. So again, he can't do it. He can't do it. So what do we have to do? It's because these operators, you see these operators were not created with your class in mind. All right? C++ could not imagine that some person somewhere in the world will create a class called rectangle that has two data members. So let me overload this less than sign to work with that class. In the off chance that somebody creates a class, let me overload it. C++ does not know that you're going to do that. So whose responsibility does it become to tell the compiler, hey, compiler, if you ever see a rectangle to the left of this dude and a rectangle object to the right of this dude, run this code. Or if you ever see a rectangle object to the right of this operator, run this code. Or if you see a rectangle object to the left of this operator and a rectangle object to the right of this operator, run this code. Whose responsibility is that?
Class?
And who created the class?
Us, user.
The programmer. So
Yes,
what
sir.
I'm trying to show you is that whenever you create a class, right? Whenever you create a class, certain things that you were expecting, like to print the object like this, will not happen automatically. The compiler does not know what the hell to do. All right? So it's your responsibility to tell the compiler, when you see my class's object in this situation, do this code. All right? So we're going to overload the operator. Now, how do we overload the operator? Well, let me explain to you how this even works. We know that objects call functions less than a minute. All right, so yeah, as soon as this, I'm just going to talk until it runs out, right? So we know that for a function to execute, for an object to execute a function, it's always object dot member function. That's always how it is. Object dot member function. So how does this get interpreted? Or this one, or this one? How does the compiler interpret those? All right, so I'm going to explain that to you guys shortly. Let's let this run out. Actually, I'm going to stop it here and let's restart this thing one time. All right, so adios way, be back. Come on, I used to play video games, but then I stopped. You have to be very careful of video games.
Why, sir? Because the
Tina is making the track.
No, I feel, but it's just that you can become really addicted to it, and it becomes like it's a way of releasing stress, and it's a way of killing time or not. It's a way, how can I say it? Video games is a way for people to relieve stress and for people to not face up to their responsibilities, like, so they feel stressed because they procrastinate, and to not think about the fact that they're procrastinating, or that they have a lot of work to do, or that they have stress in their life. They play video games, so temporarily numb themselves to the situation they're facing. It becomes addictive over time, right? So, and the way these games are designed, games are almost like Facebook. Facebook has been designed using psychology. This is not even a joke. They use psychology to play with your mind so that you become addicted to likes and responses. Like literally, that's why if you look at the history of Facebook, a lot of the top executives have left Facebook because they keep on using psychological techniques to get people hooked on. So these things, the likes and the responses and these comments, just it makes people feel special, or it can actually affect them and so forth. So games are the same way, right? Achievement points or this or that. And so I'm not saying don't play games. I'm just saying play it in everything you do it in moderation.
So that sounded
Anything
like
in
a
excess,
personal.
anything in excess is completely lethal. Anything in excess, all right? Even with drinking water, that's a fundamental part of your body's development and survival. If you drink too much water, you're gonna die. All right, simple as that. Okay, let me go back to what I was doing. All right. Let me share my beautiful screen. Share screen. Can you see my screen, you little minions? 21 messages already?
Yes, sir.
What are you guys chatting about? Go finish all programs set. That's true. All right, good. So back to this, right? Now, when the compiler sees this, remember what I just explained to you. For a function to run, right? For a function to run, the way it works is it's always object dot the dot operator and the name of the member function. So that's why you see it like this. When you look at these operators, you think, how does that work though? But what he actually does here is this. Let's look at this. Let me show you how this gets interpreted. This line actually gets converted to, and you're not going to find these things online because this is like, I'm like a genius, you know? R1 dot, still happens, right? Dot operator. You see how this guy already puts this already for me? Operator, all right? Less than R2. This, look carefully at that. Let me just make it bigger. This got converted to this. All right, because I told you just now. I said, once you're an object, the way a function is called, it's always object name dot operator, sorry, data member. You had a function called print, so this is how you call it: object dot operator function name. All right, that's exactly how it works. Simple as that. But now you're probably looking at this and going, what do you mean call a function? This is a less than sign. But remember, the rule does not change. To call a function, to execute this, he still has to call a function on the object. Now, the way it works is all operators have this name. All operators have a function called operator. So you can overload this guy. So you'd have a function like that, called that. Then there's, hold on, let me copy this. So then you have this, that. You get the point, right? So for every one of these that you call in your code, every one of these things that you call, see? All right, for every one of these things that you call, he's going to go, right? Because this is the rule. This is the rule. For operators, he knows that the function name will always start off with the word operator. All right. So when he sees this, he goes, less than. He's going to come into this class and he's going to look for, what is he going to look for? He's going to look for what? A function called operator, what? Less than. That's what he's looking for. All right. And he's going to look for a parameter like that. Oops. Bool. That's what he's looking for. All right. He's looking for this guy. He's looking for this guy because when you write this code, he sees that you're trying to compare two rectangle objects. So he's looking for a function called operator less than. If I had written greater than, he'd be looking for this, a function named this. If you had written less than or equal to, he'd look for a function like this with this name. If you had written this one, if you had this code, right, he'd be looking for a function with this name. Do you understand what I'm showing you so far? Is all of this making sense to you? I'm just trying to add on, build up upon this topic so you really understand it. Does everything make sense I'm telling you so far?
Sir, operators of the bool?
No. It depends. All right. What the frig? You can write on my screen. Annotate.
Sir, ano ba na i-show pa yung screen? My bad.
All right. Let me disable annotation for other. There you go. All right. So having said that, right? Do you understand what happens when he sees this? When he sees this, he goes into your .h file and he's looking for which function? Which one is he looking for? He's looking for a function with this name. When he sees this, he's looking for a function with this name. All right? And when he sees this, he's looking for a function with this name. Does that make sense? Does that make sense? So if you know what he's looking for, what are you going to do? You need to create these functions. Simple as that. You need to create these functions because he doesn't know what to do. That's what he's trying to tell you. I don't know what to do. So he's going to look for his functions. Now that you know how the functions should be named, right? I just told you the naming standard, right? They will all be called operator something. All right? All of them will be called operator something. So just remember, even though we write it like this, the compiler converts this part becomes this. Just imagine under the hood, this is what happens. Okay, that's what happens. You don't write it like this because this is really annoying to write, right? This becomes annoying to write. That's why we overload operators, so I don't have to write this nonsense. So how do I fix this? I'm going to come in here And I'm going to tell this guy what to do whenever he sees a rectangle on the left of this guy and a rectangle on the right of this guy. So first of all, I know that the function will be called operator something. Since I'm overloading the less than operator, it's going to be called operator less than. And since I know that he's comparing a rectangle with another rectangle, the parameter will be of type rectangle. You're probably thinking, wait, where's the second rectangle, right? Look at this. Let me show you again. Try to work with me. You're probably wondering, where is the second rectangle, right? In this, you're accepting a single rectangle to this function, but where's the other rectangle I'm supposed to compare this against? Well, look at this again. Look at it again, what I just showed you. I said this, look at it, this got converted to what? This. So in this case, who is the caller? Who is the caller of this function? Who is the caller? Who's the caller, you minions? Let me check your chat. R1 calls. Okay, so the caller is R1. Since he's the caller, all right, I already know which object I'm dealing with. This guy's the caller, but this guy has to be passed in. This is the guy that has to be passed into the function. All right. Remember, this is the name of your function. So this is the parameter you're passing in R2. So R2 would actually go in as this, but the other rectangle is you, the caller. So let me quickly implement this. All right. Hold on 1 second. So what am I going to do in here? I need to return true or false, right? Let's discuss this. Let's come up with an idea of how would we tell if one rectangle is less than another rectangle? How would we do that? What would be like an idea? I mean, let's just come up with an idea. How would you say one rectangle is less than another rectangle?
The area.
The area?
Comparative
Okay, we could do the area. Length times width, and then we see if the length times width of that is less.
Yes.
Or we could just compare to see if the length of one is less than length of the other one, the width of the other one, right? Whichever one.
Yes.
So let's just make it simple and say, okay, if this dude's what? Length, right? So R is the name of my parameter. If this dude's length is, but this is the problem. I can't say, okay, this is the thing, right? So who's the other length that I need to compare this guy against? Let's talk about it. Who's the other length that I need to compare this guy's length against?
Wait.
The current object, right? The current object. This is the current This is the current object. All right. The guy on the left is the current object. The guy on the right will be the parameter. All right. That's how it is. The guy on the left, current object, guy on the right, parameter. Guy on the left, current object, guy on the right, parameter. So in this case, I need to see if the guy on the left is less than the guy on the right. The way I have it written here is I'm checking to see if the guy on the right is less than the guy on the left, which is not correct. But anyway, how do I get access to the current guy? The current object's length. I just do length. Because length refers to the current object's length. But this is reversed, right? I don't want to do it like this, right? Instead, I want to say length, which is the guy on the left, if his length is less than the parameter's length. Let's go a little bit more. We can say and width is less than R's width. Right? If that's the case, I'm going to return true, else return false. Okay? So if the current object's length is less than the guy on the right or his parameter's length, and the current object's width is less than the parameter's width, then I return true, otherwise I return false. So now if I come back to my code, all right, I'm going to erase this. Let me comment about this. will R1, will this print less or not? Based on my logic, this just got converted to what? This just got converted to R1 dot operator. This is the function he's going to call. He's going to call this, and he's going to pass in what? R2, right? And remember, R1 now, R1 is the current object, so it's going to be his length. And who's going to come in as R? Who's going to come in as R? R2, all right? So is this going to print less?
Yes.
Or yes, it's going to print less. So let me just show it to you. Let me comment on this because he's crying about this thing right now. All right? He prints less, right? Okay, I didn't do a new line, but anyway, he prints less. So he prints less. Okay, now he knows what to do. Now he knows what to do. Does that make sense? So now if I wanted to compare if two rectangle objects are equal, I would write this. I'd say if R2 is equal to R3, Cout equal. Now again, when the compiler sees this, the compiler is going to look for what? He's going to look for a function in your class. He's going to look for a function called what? Operator equal equal. That's what he's going to look for, right? And he's going to come here and go, where's that? Oh, you don't have it. Bastard, what are you trying to do, right? So what do I have to do? I have to create this function, all right? I need to create this function. So I'm going to come in here. I'm going to quickly create that. I'm going to say bool, and same thing, all right? I'm going to do that. And I'm going to come here. And what I'm going to do is I'm going to say if, same thing, if the current length is equal to the parameter's length and the current object's width is equal to the parameter's width, I'm going to return true. This can be done all in one line, but I'm just showing you. Okay. So now if I come here, will this print equal? Let's see. I'll come here and say else, just to show you. Else. Not equal, right? So is it going to print equal or not equal?
Not equal.
Not equal, right? Let me just do a new line, just so that all of this stuff doesn't get crumbed on the screen. It's going to look weird. All right. So. Okay, so now when I do this, now the compiler, right? If I compile this, now the compiler knows he's going to look for this function, right? And he says less, yes, but not equal, not equal. To prove it, to prove that this thing actually works, right? Because R2 was 5 and 4, I'm going to change R3 to be 5 and 4 as well. I'm going to change this to 5 and 4. And I'm going to run this again, and now we should print equal. Equal. See that? So now what am I doing? I have overloaded this operator to now have the ability to work with rectangle objects. I've overloaded this operator to work with rectangle objects, and I can do it for all the other operators. In your assignment, in your program, said I asked you to overload, I can't remember what I asked you to overload, but I asked you to overload something, and you have to overload that something. Now, which one did I ask? Let me see. The assignment and the less than. Okay, so I already gave you the code for less than, but you have to apply to a linked list, right? You have to apply to a linked list. I don't know what I told you about the role for less than. I don't know if I explained it. Oh, okay, printing. Perfect. Let's quickly do that, right? Now, first of all, do you understand what I just said? Does it make sense?
Sir, why did it print less when you run it? Like it prints less
because R1, right? R1 at a default constructor, right? And default constructor sets the length and width to 0. So R1 got 0, 0, and I compared R1 with R2, which was 5, 4. So then this would print less. This would be true. This would be true because look, this is true. The current object's length is compared against the parameter's length, and the current object's width is compared against the parameter's width. If this is less and this is less, we return true.
Oh, I hadn't seen you assigning the 0 today.
Oh, yeah. So that for the constructor, for the default constructor, I just give them both zeros, but the rest I assigned length and width. So now, does this make sense to you guys so far? Okay, so now let's do this. Now I want to print the rectangle object. Let's say I want to print R2, right? Now, this is where it gets a little bit tricky. I could overload all of these operators the way I just showed you. Same principle over and over again. But this guy's a little bit tricky. Now, why is this tricky? Let me ask you a couple of questions and see if you can answer it. What is cout? This is a programming 1 question. What is cout? Quickly. We're running out of time, minions. Quickly. What is cout? Don't tell me what it does.
Screen.
Don't tell me what it does. KNS. KNS.
It prints the result.
No, don't tell me what it does. Don't tell me what it does. What is it? What is cout? Come on, F47.
An operator.
It's a what?
Operator.
Cout is not an operator.
Console output.
It's a what?
A command?
Console
Not a command.
output.
No, it's not a command.
A function.
Roy says it's a code word. Everything is a code word, damn it. Oh, Pedro, check out Batman Pedro. Pedro gave the answer, right? Pedro is correct. Cout is an object. Scene is an object. Where do these objects come from?
STD.
STD, oh my God. STD
Oh,
produces
no,
a
no.
lot of
OS
things.
stream? No.
IS3, my bad.
No. STD is, you're mixing up STDs.
OS
All right, and that's never a good thing. So, it comes from the IOStream library. Every time you want to use scene and cout, you just have to include the IOStream library, and automatically those objects will be created and made available to you. For any other object of any other class, you have to explicitly create the object. But because C++ realized that printing and grabbing stuff from the keyboard is such a fundamental and common action, that they wanted to make the lives of programmers easy. They just said, all right, instead of creating the object cout, instead of creating the object C, and just include the library and it's automatically going to be created and available. But any other class, like a string, you'd have to do it. You have to create the object, right? You have to create a string object. It's not available to you automatically. So having said that, we now know that cout is an object, right? You with me so far? I'm trying to build up to this, you know. Do you understand? Cout is an object. Where does he come from? Which class? Which class, minions? Come on, which class?
IOStream.
IOStream.
Right.
All right. Now look at this. How does this get converted? This is how this gets converted. You ready? Ready? Drum roll. I'm playing the drum right now. Cout dot. Tell me how can I finish this? What is he looking for? Cout dot what? What's the rule?
Print F.
No.
Operator.
What?
Double.
This one.
Brackets.
And then who's there?
R2.
R2.
Oh, we've got a problem, a big problem. Now, look at this. You see this? You see this? This got converted to what? Rectangle object, operator, rectangle object. This got converted to, I'll show you, to R2, which is a rectangle object, with another rectangle object. Does that make sense? But look at this guy. Who's on the left? Let me rephrase that. Who is the caller? The caller for this guy is R1. The caller for this guy is R2. Who's the caller in this line? Who's the caller?
IOStream.
No. Who?
Cout.
Cout, because I said cout is an object. Cout is the caller. This is a problem. Because, let's go back to this code. Why is this a problem? When you came here, right? When you overloaded this guy, this function, in order for him to figure out that one rectangle is less than another rectangle, he needed access to what? What did he need access to? He needed access to your data members. But your data members are what? Private, correct? But since these two guys are rectangle objects, this function can appear within the rectangle class. No problem. The problem here is this function is being called by a non-rectangle. This is being called by an outsider. This is like basically saying some stranger has come to your house and he wants to use your toilet. All right? He wants to use your toilet. All right? This is different. This one is your family member, your cousin has knocked on your door and he wants to use your toilet. No problem. We're both from the same family. Come in. So this can work. You have access to my private data members. But this dude, you're not part of my rectangle class. You're part of the IOStream class. Who the hell are you? Remember, if cout wants to print a rectangle, he needs access to what? He needs access to your length and he needs access to your width. But those are private inside of the rectangle class. This guy needs access to those. How do I do it? Now you'd probably think I'll do it the same way like you did here. I would do operator that, and I'll do rectangle temp. I'll do this, and then I'll do, what should this return? I'll put void for now, just to show you why this is not a good idea. But anyway, we're going to work on this. Guys, I might have to go over this 5 minutes because this is very important. Anyway, I'll have to do that, right? Now, the problem is if I left it like this, let's say I left it like this, okay? If I left it like this and you looked at my code, what is your understanding of this function declaration? That this function was created inside of the rectangle class, correct? That means that he's expecting that when this function gets called, it's going to be called by a what? He's expecting this function is going to be called by a what? What is the expectation when you do this?
By a rectangle.
By a rectangle, just like this guy, just like equal and less than. He's expecting that you're going to do this, right? This is being called by a rectangle. This is being called by a rectangle. So that's what he's expecting now. But look at how you're using it. You're not saying this. You didn't write this. You didn't write this, right? You didn't write that. That's what he's when you write this, when you do this, that's what he's expecting. He's expecting this kind of nonsense. He's expecting that there's a rectangle to the left of this guy and a rectangle to the right. Is this what you're trying to achieve? No. There's no rectangle on the left. There's a cout object, an object of another class. What am I going to do? That means this is not part of the rectangle class. Okay? I need for this guy to know that somebody else is going to be calling this.
Can we
right?
use
And
the
the way I
friend?
do that is I have to tell him, hey, buddy, I don't want you to expect that a rectangle. I don't want you to expect that there's a rectangle object to the left of this guy. No, you can't expect that. This, wrong. Sorry, this, wrong. I don't want you to expect that. I want you to expect somebody else to the left. So how do I tell him? Expect somebody else to the left. You need to tell him who's the other person. So what is cout? Cout is an OStream object. I'm going to call it out, right? Call it whatever the heck you want. You know what? I'm going to change it to something else because you guys are dodos. You're going to think it's always going to be called out. All right? Mule fart.
Sir.
All right? We're going to call it mule fart, right? Just so you know, this can be any name you want. OStream. Oh, he doesn't know what the hell OStream is. So pound sign include stream and then using std stream. All right. Okay. So I have this. All right, and I'm telling him to overload. It's going to run out in like 10 minutes. Okay. So this is saying now what this is saying is right. What this is saying is that the caller now is no longer a rectangle object, but it's somebody else. Who's that somebody else? Who's he expecting to the left of this guy now? Who's he expecting?
Cout.
Huh?
Cout.
Cout, an OStream object. He's expecting an OStream object. All right, that's what he's expecting now, an OStream object. And he's expecting that to the right of that operator, there's going to be a rectangle. And now it's your job, right, to tell him what to do. The problem is because this is being called by another object of another class, and you need that guy to have access to these private parts. You can't just leave it like this. You got to say, this function is my friend. Okay? You got to say, this guy's my friend, people. All right? So now what's going to happen here is, since he's your friend, what you're saying is cout has access to these two. All right? So I'm going to come here. Let me quickly implement this. All right? And I'm going to implement it. So what am I going to do here? What is he complaining about? Overloaded operator must be a binary operator. Okay. What is the problem here, guys? Who can spot this error? Whoever can spot this error, I'm going to have to shake his damn hand. All right? And then slap him in the face because we don't like overachievers. So I'm going to congratulate you and then I'm going to insult you. What is the problem here? When you see this, what does that mean? When you see this? When you see a function being implemented and you see that, what does that tell you?
It needs to be on the private.
No.
It's a function from rectangle class.
Well, yes, this is saying that this function belongs to rectangle class. That means if it belongs to rectangle class, that means it can be called by what? A rectangle? Object. Lies. You can't be called by a rectangle object. You can only be called by a what? Cout or OStream object. So you can't put this. When it's time for you to implement, you can't put that nonsense because he does not belong. He does not belong to the rectangle class. Does that make sense? So I have to remove that part. No, but this guy says this function can be called by a rectangle. This function can be called by a rectangle. That's why it's in the rectangle class. But this one, we said he's a friend. We said this guy's a friend because this guy, what we're trying to say is, this is one of those functions that can be called by somebody other than a rectangle. So now what am I going to do here? I'm going to say, oh, I can't say cout. I can't say cout. I'm going to say who? Mule fart, right? Mule fart what? I'm going to say length is, this is how I'm going to print a rectangle. This is my version of printing a rectangle. Length, right? Mule fart, oops, mule fart. If they do evaluations, don't tell those people that I call these things weird names. Just say he uses sensible names. All right, there we go, right? Oops, sorry. What is he complaining about? Quickly, tell me, what is he complaining about?
The rectangle objects.
Okay. I want people to piece these things together, and I don't want to piece all of this. Okay, how come
You have them
when I
that
use the word len, he never complained inside of this function? Why didn't he complain? Why didn't he complain when I use the word len? But he's complaining here. Why? Give me a good answer. Why?
He knew what object we called it. And
Yes,
now we're not
he knows
using
that
the same
len-
object.
Yes, that this comes from a rectangle object, right? Because this function can be called by a rectangle class. But this len, who the hell is len? This function does not come from the rectangle class. This is some independent function. This has nothing to do with the rectangle class. So when you say len, the compiler is going to know who the hell is len. So you have to be very specific. You got to say temps len and temps width. All right. Now he goes, oh, okay, this dude. So now when I come here and I do take out this. So now this got converted to this. So the caller is cout and the parameter is rectangle. He comes in here and he goes, hey, you got a function that can deal with this craziness? He says, yeah, I got this function that accepts a OStream object and it accepts a rectangle parameter. This is the function that gets called. So when he sees, when you write this, it gets converted to this, and he says the color is at OStream object, and the parameter is a rectangle. Do you have such a function? Yes, sir, I do. Here it is. And then he's going to run your code, and this, you decided that the way you print the rectangles by printing the word length is with is, right? You can put whatever you want. So now when I run this, when I run this, for R2, I should see 5, 4, right? I should see, come on, 5, 4. Now he can print rectangle objects because you told him how to print a rectangle object. Does that make sense? Now, do you guys want me to show you how to overload the CN operator?
Yes.
This is going to take about 10 minutes for me to show you the CN operator. All right. So when this time ends, just come right back into class, and then I'm going to show you how to overload the CN operator. But for that one, you're going to answer my questions. All right. Because I walked you through this whole process from scratch. I taught you all of these things. So now you're going to show me how to create the operator, the cout, overload the cout operator. Right. So let's go. And when this ends, we just restart it. So what if I want to do this? What if I want to say, cout, please initialize the rectangle, right? Okay, I see that. I go, okay, you want me to initialize the rectangle, and I do this. Now I could have done this, right? In the rectangle class, I could have created set length, set width, and I could have done R2 set width, right? Val, right? I could have done this. I could have done this. R2, R2 that set set length, set length, val, right? I could have done that. And then here I would have done cin val, cin val, right? So I could have done it like this. This is one way I could have done it. Please enter rectangle length. Sorry, width. I could have done it like this, and then same thing. All right, I could have done it like this. But right, so I want you to understand what's going on. I could have done it like this, but that means I would have had to have created a what? A set width and a set length, right? But what if the same way you can do this, right? You could do this into X and Y. Wouldn't it be cool if you can do that with a rectangle object that I could just write cin R2, R3, R4, and so forth. Instead of doing this set width, set length, I could have done this and let this function handle it for me. That is our goal. So that's what we're going to try to do right now. So we can avoid this. We're going to overload this guy. Okay? We're going to make this functionality appear inside of this. But before I do that, there's one more thing I need to explain to you about. Let me just do that. There's one more thing I want to explain about this guy, right? I forgot to show you. Very important. Do you notice I have void, right? Now, why is this a bad idea? This time is going to run out right now. But anyway, let me just restart this thing. Not waste time. Hold on. And
Yo, off your mic, bro.
Okay. Almost everybody. Let me just make sure everybody comes in because we know this is important stuff.
Hey guys, turn off your mic.
Okay. Okay, so let me
Right.
Hey, come on this side. Afternoon to go walk about. Come on.
Sir, you have to set it up so it automatically mutes people when they enter.
okay, I should do that.
No, my laptop also turned on the mic automatically.
Yeah.
Okay, guys. So let me share my screen again. Let me come back to this because this is an important thing. There's one thing. Notice that this thing returns void, right? That means it doesn't return anything. Now, why is it not a good idea to have it return void, right? Where is it? No. Okay, so now the problem is this: if I can print R2, what if I want to print R3, right? Because the same way you can do cout X. What if I want to print Y at the same time? What if I want to do cout Y as well? The way this works, right? Say he can do this, right? This, for example, would be converted to. So this would be converted to cout. Just want to show you. Operator X. Dot. That's what this would look like. Like under the hood, this would be converted to this. Okay? Cout is the object calling this operator on this operand. And when this is done, what is he going to do? He's going to call this, correct? Why is he complaining about my stuff? It worked for one object. Why doesn't it work for another object? Because this is what happens. Let me show you. This is very important. See if you understand. This gets converted to R2, all right, dot it gets converted to that. Now, what is the problem? When this function gets called, what does he return? Nothing. So what happens here is when this runs, he will print it. He's going to print R2. But this, when this finishes, this function returns nothing. So then this gets converted. Imagine it like this being converted to null dot operator.
So
You see
do
the
we have to
problem?
yeah. So do we have to
This
return
runs,
cout?
yeah, so but now you return nothing. So this is void. This is void. Nothing came back. So you're saying, you're telling void, hey, Mr. Void, I want you to call this function and we're passing in R3. Compiler's gonna go, what the hell? It worked for this because remember, you and I didn't create this guy. They overloaded this so that it works with as many operands as we want. So in this case, how do I fix this? Instead of returning void, then you should always make these operators return a reference to an O stream, not a copy. Do not do this. You never want to create copies of streams. All right, you want to work with an actual stream. So you always want to return a reference to the stream. So the same stream that came in is the same stream that goes out. You don't want one stream to come in and then you send back a copy of another stream outside. So then I'll come here. I'm going to change this to, instead of void, I'm going to change this to O stream like that. Okay. And then here, I'm going to return mule fart. Now, what happens? What is mule fart? Let me ask you this question, right? What is mule fart? It's a very dumb question. It sounds very weird. If somebody was just listening to this conversation and think this is crazy. What is mule fart?
cout.
It's cout. So you're really returning cout, which is an OStream object. So now what happens here is this will run. Then who comes back? Who comes back when the first one runs? Cout gets returned, and then cout can call it on R3. So when you do this, it gets converted to that. So this first part runs, you'll print it, then he returns cout, and then cout is called on this guy. That's what it becomes that. So that's why now if I do this, so now look at that. I can go as much as I want. I can do R1. I can do R2 again. I can do R3. Doesn't matter. All right? Doesn't matter. Because he keeps on returning the OStream object. So now you notice it's printing all of them. Does that make sense? See, it prints all of them. Does that make sense?
Sir, you can send me this code.
I can send you this code if you want, yeah.
Yes, please.
Now.
Yes, please, sir. I had to tie a screenshot.
So one more thing we can do, which I said was, where is it?
Cn.
Cn. I want to overload Cn now, right? I want to be able to just say cout, please initialize rectangle. Okay, so I see this, and I do, all right. And I do Cn, this is what I want. Ultimately, this is what I want. I want to be able to do this. R1, and I want to go crazy, and I want to still go R2, R3. I want to be able to do that even if I want to, right? Right now, we don't even have this working. So let's focus on this, right? So the first step is what? I need to overload who? This operator. But I need to also be aware of the fact that in this example, this is converted to Cn is the object, operator, and R1. Okay? That's what that gets converted to. Does that make sense? So I need to create the equivalent in my class. So I'm going to come here, and I'm going to, same principle as before. All right, I'm going to put that.
iStream.
This time, I'll change it to this. This time, he's not expecting an O stream, he's expecting an iStream.
Yep.
I'll just call it in, just so it makes more sense to you. And you're going to return an iStream as well. All right, that's what you're going to do there. I got to do the same thing here. He doesn't know what the hell an iStream is. All right, iStream. That's that. All right, so that's gonna, and I'm going to remove this because this doesn't belong to the rectangle class. And then I have this. So now what are you going to do here? Just pretend in is cin. What would you do here? You would say, you could do cout as well. Right? You could use cout in here, but please enter length. In
Temp.length? No.
See that I'm just showing you what's actually happening. I'll say temp dot length is the same. Read it again. Please enter width in val temp dot width. Now what happens here? This code is written once, but then I could now if I run this, if I run this, oh, and I need to return, and remember I have to return the iStream object so that we can have a scene followed by another object, another object, another object. So I can say return in so that I can cascade it. In this case, all right, so now he recognizes, he goes, oh, okay, I know what to do here. So I can just run this. So please enter length. I'll put, let's try like some 9.97, just so we can tell. Please enter width, 5.93. And now you notice it because this was, which object was I doing? This was R1, and I printed R1 here. This is where I printed R1. So now it's going to print. Length is 9.97, width is 5.93. And I can go again, and I could do R2, R3, and it doesn't matter, right? And I can compile on this. Okay, so I'll do 3, 4, 7, 9, 19. All right, so I'm seeing there. So these are the values that I put in, and it does that. Any questions about that, guys? Does this make sense?
Yes. You're gonna send this, right, sir? Because I gotta go.
Sure. I'll send this code to you guys. All right, guys. So that's it. Again, your program set is due on Saturday. I think it's Saturday. Just make sure all the function calls, at least, even if your function does not work, create the body of the function and comment out the inside of it. So make sure it has a shell, opening curly brace, closing curly brace, comment out the body of it. All right. And then you send that code to me with your names and everything. I'm going to check it. Okay. I'm going to send this code to you guys so you can have it as a reference. That's it, guys. Take care. Hopefully this was good because I spent a lot of time explaining this topic to you guys. All right. Adios.
No, sir.